If you were a drafter working for a steel fabricator, one of the things you'd be drawing would be details of beams showing where are the holes. And to do that, you start with a design drawing. And what we are looking at here is two different styles of design drawings from an engineer. The one on the top is a plan view. It's looking at a part of a beam framing plan from above, and it's a single line drawing. And what we see is a column, then a single line representing a beam, then another single line representing a girder. And notice that there are spaces between the ends of the beam and the things they connect to, representing the fact that there is actually a gap at each end. The drawing at the bottom is a double line drawing, and it's an elevation view, not a plan view. However, and this is just for illustration, you wouldn't combine those two like this on an actual drawing. The one on the bottom is an elevation drawing of the section of the beam framing plan that you see in the top. So here in the top view is the top view of the column. Here in the elevation is the front view of the column. In the plan view, there's a line representing the girder. In the elevation drawing, there's an end view of the girder. And then here is the beam connecting to each of those with framing angles. And notice that where the beam connects to the column, the framing angle is bolted sort of in the middle of the web. Over here where the beam connects to the girder, that top surface needs to be flush because we're going to put steel decking and floors up there. So to make that flush, you cope or notch that beam. Here is a 3D view of that kind of connection. Here's that same elevation view again, and here's a 3D view of a beam connecting to a column, and then on the left a 3D view of a beam connecting to a girder, and that beam is coped or notched out so it will be flush. All right. What you need to know about detailing steel is that everything is standardized. A structural steel building contains thousands of pieces of steel. And in order to be economical at all, we've got to be able to produce these in mass quantity fast. So the steel fabrication company will have certain standard sizes in stock. They'll have certain sizes of framing angle in stock, and they will use fixtures to do all the coping and drilling. I'll show you that next. So the framing angles these are the three standard sizes that you might encounter for one of these connections. And then you can cut that framing angle at several different lengths. In the steel fabricator's shop, there are fixtures, big, metal frames that hold the beams so that they can come in and drill holes real fast over and over again in the same spot. So in order to make that fixturing possible, we always locate the holes the same way every time. We always do three things. One, the first hole of a framed connection is always 3 inches down from the top of the beam or girder. 2, the spacing between holes they are always 3 inches apart on center. And 3, it is always 1.25 inches from a hole at the end of an angle to the end of the angle iron on each end. So look at the framing angle in the bottom view here. It's 1.25 inches from the top hole to the end of the angle, and it's 1.25 inches from the bottom hole to the bottom end of the angle. And then the holes are always standardized. We always use 3/4 inch bolts to fasten these unless there's some special situation. And the hole is always 1/16 of an inch bigger than the bolt. So that means these holes are always 13/16 diameter. And in the steel fabrication world, unless you're using some special size, you don't call out those sizes. Everybody knows that's what you're drilling or punching. Okay, so these framing angles are always 1.25 inches from each end to the first bolt hole, and then the bolt holes are always 3 inches apart. So what that means is that there are only a few standard lengths that you might cut this angle, depending on how many bolt holes you had in there. If you had only 2 bolt holes, you would have a short angle, 5.5 inches long. If you had 4 bolt holes, you would wind up with a framing angle that was 11.5 inches long. If you had 5 bolt holes, it would be 14.5 inches long, and so forth. That's because it's always 1.25 inches to each end of the angle, and then 3-inch spacing from hole to hole. That's how you wind up with these lengths. Then the gauge, which the AISC Steel Detailing Manual will tell you about, the gauge is the spacing from a row of holes to the other row of holes. And we'll see this again when we look at our detailing drawing in the next video. The cope is this notch that we cut out. We've referred to this a couple of times already. And AISC gives us standard ways to figure out the sizes of the copes. Gets a little bit hairy, multiplying this times this. Don't worry about that right now. One of the things AISC says is you look at the girder that the beam is being connected to, and in your steel book, it will give you a distance, they call it the K distance, that it's the distance down to where the straight stuff starts. So in the underneath of the flange here in the beam, there's a radius, it's curvy, and at some point it stops being curvy and it starts being flat and straight. That's the K distance, and so we make our cope that depth, more or less. We round it off to 1/4 inch increments, but more or less the K distance. And then the width of the cope needs to be wider than the flange sticks out, so we go half of the flange width, and then we add an extra 1/2 inch or so of space just to allow for mill tolerance and erection tolerance. You need a lot of wiggle room for the people out in the field who are trying to get these beams swung into place with cranes. So you'll notice in all these drawings, you'll see a lot of open space to make it easier